Okay, in this one, we're going to look at molecular formula, which isn't much different. It just has one extra step. So again, we are going to assume that we're dealing with 100 grams. Okay, so that means that we have carbon. Instead of having 75.46%, we now have 75.46 grams. And then again, we're converting all of these to moles. So we're going to divide through by the molar mass. Molar mass of carbon is 12.01 grams per mole. And we're going to get a calculation. That equals 6.28 moles. Okay, because we're still dividing mass divided by molar mass. And that equals moles. Okay, and then we take our hydrogen, we do the same thing. Instead of 4.43%, we have 4.43 grams. We're dividing that by 1.01, its molar mass, and we get 4.43 divided by 1.01, 4.38 moles, or close enough. You can round that up to 4.39. It doesn't really matter at this point. Again, let's not get bogged down in sig digs and exact numbers. We just want to make sure that we have approximate values. Okay, 20.1. And the last one is oxygen, which is 20.10 grams. We divide that by our molar mass, which is 16, and we end up with, and that equals 1.26 moles. All right, so now we're at the stage where we are going to divide through. We need to change these values here. We need to change these values here to whole numbers. And the way that we change them to whole numbers is we divide through by the lowest number. So we're going to divide through by 1.26. Divide through by 1.26. Divide through by 1.26. And that is going to lead us with 1, 3.47, and 5.02. So this has created a little bit of a problem right now because we have 1, which is obviously a whole number, 3.47, which is not even close to, it's not really a roundable number, and we have 5. So for all intents purposes, this is almost exactly equal to 5. This is approximately equal to 3.5 because we're just going to round it, and this is obviously equal to 1. Well, we still can't have this. We can't have a half number. So what we are going to do is we are going to, well, how do I make half numbers whole? I multiply by 2. And I multiply by 2, and I multiply by 2, and that's going to give us 2, 7, and 10. So that'll help us out a little bit. So right now what we have is we have C10, H7, and O2. Okay, so that is our empirical formula. Okay, so the only problem is that it is asking for the molecular formula. Now the molecular formula is some multiple, it can be 1, it can be 2, it can be 3, of the empirical formula. So how do we figure that out? Well, what we do is we do the molar mass of C10H7O2, and we compare that to the molar mass that is posted in the question, which is up here. Okay, so we're going to do a quick calculation, and that equals, and that equals 159.17 grams per mole. And how does that compare to the molar mass which we saw back up here, which is 318? Well, hopefully you guys can see the quick math. 318 divided by 159 is 2. That means that the empirical formula is half of what the real molecular formula is. So we're going to take the molecular formula, which is C10H7O2, and we're going to multiply all of that by 2. So now we're going to end up with C20H14, that should be a 14, and O4. And that is our molecular formula. So we start off with, start off with calculating our empirical formulas. Assume that we're dealing with 100 grams. Let me get my highlighter out. We assume that we're dealing with 100 grams, and then we find the moles, which is what we did right here. Okay, so we find the moles of everything, and then we recognize that we have a bit of a problem here. We have a problem with this number here. So if it's close to 3.5, or if it's close to 3, or if it's close to 5, or whatever it's close to, we have to sort of like think to ourselves, does that really fit into how I've seen formulas before? We are going to change that. So we multiply by 2, so we get whole numbers, and that gives us our empirical formula here. Take our empirical formula, find the molar mass, and divide through by what the question is stated what the molecular mass of the question is. Again, we're not really that interested in making sure we have exact numbers. These are sort of end up being a little bit roundabout, but we just have to make sure we're going through those steps.